All right, so going over our lesson from today. We actually did this lesson at the very beginning of the year as one of them that I already chose as an 8th grade practice lesson. Turns out in the state of Kansas, this is actually an 8th grade standard. So instead of going through the try it, discuss, and connect it, we're just going to pretty much hit the connect it, review over what we went over in those first days, and make sure that you are understanding what you're supposed to be doing. So the problem we had was that Imani translated an ancient cuneiform tablet that she found. She thinks the 3 sets below describe side lengths of triangles or triangular stone sculptures. So this was the one that started getting us very frustrated when we were practicing, because 2 of them, you kept trying but couldn't make them connect. And so here are examples. Now this one could look slightly different depending on if you were trying to put your 3 and your 5 together before you put them with the 10. But either way, we got pictures like this. Our 3 and our 5 aren't close enough together to even connect. Our 7 and 3 make exactly 10, so for them to connect, it's going to be directly on that line that is 10. And then 3, 5, and 7 was the one triangle we were able to create. So then when it comes to the analyzing of it, and we look at this and the math that goes with it, 3 plus 5 is less than 10, because 3 plus 5 is 8. 3 plus 10 is greater than 5, and 5 plus 10 is greater than 3. And then when we look at 3, 7, 10, 3 plus 7 equals 10. 3 plus 10 is greater than 7. 7 plus 10 is greater than 3. And then when we get to the one that worked, so neither one of these worked. We get to the one that works, 3, 5, 7. 3 plus 5 is 8, that's greater than 7. 3 plus 7 is 10, which is greater than 5. 5 plus 7 is 12, which is greater than 3. So when we notice this, all combinations were greater than the third side. Whereas over here, we had an equal to, and here we had a less than. And those triangles didn't work. We weren't able to make triangles with those. We have to have 2 of my sides added together have to be greater than the third. And it has to happen every time. Because here it happened. It happened twice on both of these. But because it didn't happen that third time, it didn't work. So then when we go to answer our questions, why is it impossible to draw a triangle with sides 3, 5, and 10? And the reason is because 3 and 5 aren't long enough. The sum of 3 and 5 has to be greater than 10. And so the lengths 3 and 5 are not long enough to meet. They have to add to more than 10. So then it comes down to, why is it impossible to draw a triangle with side lengths 3 and 7? And with 3 and 7, the lengths 3 and 7 are just at 10, which makes them the same length as the third side. They also have to add to more than 10 in order to work. So then when we look at this, why was it possible? Why is it possible to draw a triangle with side lengths 3, 5, and 7? And it was because the lengths 3 and 5, when added together, are greater than 7. Oh, that's going to be great. Therefore, they create a triangle. So then question 4, without drawing, how can we show if it is possible to form a triangle with side lengths 5, 7, and 10? Explain why. Well, up here we're saying each time we have to add together and be greater than 7. So really, I just need to double check. Is 5 plus 7, what is it to 10? And is 5 and 10, 5 plus 10, what is it to 7? And 7 plus 10, how does it compare to 5, right? So 5 plus 7 is 12, right? And 12 is greater than 10. 5 plus 10 is 15, which is greater than 7. 7 plus 10 is 17, which is greater than 5. So how can I tell if it is possible? Well, I need to check. The truth of the matter is the fact that the 10s here are already greater than the 7 and the 5, I know these two are going to work. It is the same for when we were looking at these. Right? The 10s are greater than my 5 and my 3. The 10 is greater than my 7 and my 3. The 7 is greater than the 5 and the 3. Those bottom two are going to work no matter what. What it comes down to, like, I know this works because all are greater than the third side. And I was starting to get ahead of myself on explaining. But I know that this works because all are greater than the third side. Now, number 5, what rule can we make to know if 3 side lengths create a triangle? And the truth of the matter is, if I take the largest plus any of the other 2 side lengths, it is always going to be greater than the third side length. That's always going to be a given. So really, we just need to take the 2 smallest, and we need the sum of the 2 small sides to be greater than the largest side. So a triangle normally has a small, medium, large side. So I need small plus medium has to be greater than my large side. Okay? Has to work. If I don't have that, if my 2 smallest sides are not greater than my largest side, we're getting nowhere. Alright, so I will save this for another video just in case all you need are the examples. You can come back and just get the examples. I'll see you in that next video.